So in this week we're going to review some basics about functions, particularly how to evaluate them and how to work with equations dealing with them. You have a few videos that define what a function is as well. However, a lot of material we're going to be doing in this exercises doesn't focus on that. So, but mostly how to evaluate them, how to make use of them, that sort of thing. So let's get into it. So you're given that f of x equals 5x minus 3. Find f of 7. So take a moment, answer this, and then we'll go through it. So with this function notation, basically all f of 7 is telling us to do is go to the function f of x and replace the x's with 7's. So 5x minus 3 becomes 5 times 7 minus 3. 5 times 7, of course, is 35 minus 3. And then 35 minus 3 is 32. So f of 7 equals 32. Try the next one. Same thing with this. If k of t equals 13t minus 2, k of 3 is going to be the same thing as me doing 13 times 3 minus 2. Just replacing the t, in this case, with the number 3. 13 times 3 is 39, so I have 39 minus 2, and 39 minus 2 is 37. So k of 3 would be 37. Let's try another. Much like the first two examples, here I have f of x equaling 14 minus 0.5x. If I do f of 30, I'm going to replace the x with 30. And so f of 30 is going to be 14 minus 0.5 times 30. 0.5 times 30 is 15, so this is going to become 14 minus 15, and 14 minus 15 is negative 1. So f of 30 is negative 1. And for this one, h of t equals 80 minus 11t. So if I do h of 5 is going to be 80 minus 11 times 5. And 11 times 5 is 55. And 80 minus 55 is going to be 25. So h of 5 is 25. Now we're going to do the same thing as we did here, but we're going to use graphs to do it. So this next example, you're given that blue graph, that jagged line is the function y equals f of x. So find f of negative 1. Well, here, if y equals f of x, then f of negative 1 means I'm looking for the function value when x is negative 1. And basically, since the y value is taking on values of f of x, this is basically just asking me to find the y coordinate when x equals negative 1. So look for negative 1 on the graph for when x equals negative 1. That corresponds to this line right here. And if I move up along that, I can see that the graph is there at 5. So f of negative 1 would be 5. Try this next one. So with the function y equals g of x, me looking for g of 3 means, okay, I want the x, when the x coordinate's 3, I want to figure out what the y coordinate is. So here's where x is 3. So I see here the graph is down here at negative 1. So that's what the answer is. For the next one, with y equals h of x, h of negative 6 means I want to find the y value when x is negative 6. So here's where x is negative 6. As I can see, if I'm go to negative 6, I'll move down to here where the y value is at negative 5. So the answer is negative 5. And for the next one, try this one here. For this one here, k of 9. So I can see that, where x is 9, let me get a good color here. X is 9 is right here. That corresponds with that spot on the graph, and that spot on the graph has a y coordinate of 2. So this answer here is 2. Moving on to the next one. Now in this one here, you're told that g of x equals negative 9x minus 4, and you're told g of blank is 23. So basically here we're looking for, we know that there's going to be some number here. We want to figure out what the number is here that would make this equal 23 based off of this formula here. So take a moment, see if you can figure out what value of x would go in there. So with g of x equaling 23, I know I'm looking for the x value that goes in there. So essentially, I know that this negative 9x minus 4 equals 23. I'm looking for the value of x that makes that happen. So I add 4 to both sides of this equation I'm looking to solve, and I get that negative 9x equals 27. I divide both sides by negative 9, and I end up with x equaling negative 3. So basically g of negative 3 equals 23. Let's try another one. Well, for here, you know that f of t equals 14t plus 9, and that f of some number equals 58. So I know that basically that f of t equals 58 in this case, and f of t is 14t plus 9. So we know that 14t plus 9 equals 58. I'm going to solve this equation to figure out what t is, and that's the t that would go here. So subtracting 9 from both sides, I would get that 14t equals 49. Dividing both sides by 14, I get that t equals 49 over 14, which does simplify down to 7 halves, and as a decimal is 3.5. So 7 halves or 3.5 would be a good answer. I'm going to use this at 3.5. So f of 3.5 is 58. Let's try another one. So same thing here. I do know that h of x equals 8. And therefore, for me to find the value that comes in here, I'm going to need to solve the equation where this 4x plus 20 is set equal to 8. So I would subtract 20 from both sides to get that 4x equals negative 12. I would then divide both sides by 4 to get that x equals negative 3. And so negative 3 is the number that goes inside the parentheses there. Let's try one more of these. So again, I know that k of t equals negative 7. So I know basically what the result is. I'm looking for the t value that makes it work. And that means I'm looking for the value where 6t minus 1 is going to equal negative 7. So solving this equation to figure out what t is, I'm going to add 1 to both sides, which gives me 6t equaling negative 6. I then divide both sides by 6, and I get that t equals negative 1. And so negative 1 is the value that goes in the parentheses here. Now we're going to do something similar to this now, except now with graphs. So given this graph here where you see y equals k of x, tell me what value goes into parentheses to make this statement true. K of blank equals 3. Well, for this here, I'm looking for where the y value equals 3. So I'm just going to draw a line where y equals 3. And as I can see here, it's actually crossing in two different spaces. So you could probably argue in either case that there's actually two values where it equals 3. 0 is definitely one of them. That's what we were looking for here. Here looks like also about 9.5, but I didn't really give that one as an answer. But I would also say if you said k of 9.5 equals 3 as well, I'd also give you credit for that as well. Let's try the next one. Well, here we're given y equals g of x, and now we're looking for when g of blank equals 3. So drawing that horizontal line in, I can see the only spot where it touches at, this line at 3, where y equals 3, is here when x equals 9. And so that's what goes in here. The x value of 9 makes this function value equal 3. Let's try this one more time with this. Now what's different here, it's acknowledging the fact that, okay, we know that h of negative 7 equals 3 based on the graph, but there's another x value that would make this happen. So find the other input value that would make this statement true. Well, for this one here, again, y equals 3. That happens to be the y value that they gave us in all three of these. I acknowledge the h of negative 7 equals 3 here. But there's another value as I move across here, right here, where h of x is also 3. And I can actually have more than one x value produce the same y value. I just can't have an x value produce more than one y value. So happens here when x equals 5, so the number that comes out here is 5. In the last group of questions are going to be situations now where you're asked to rearrange an equation to put it into a function in terms of one of the variables you're given. So for instance here, you're given that the input value is m. The function f outputs a value n to satisfy the following equation. 7m plus 2 equals 6n minus 5. Write the formula f of m in terms of m. So take a moment, see if you can come up with a formula for f of m. Well, for this one here, we're acknowledging that n, the other variable, is going to be dependent. It's an output value. So n is going to be a function of m. So n equals f of m. And for me to figure out what f of m is, basically I just get to go to this formula here and solve it for n. So I like having my n's on the left-hand side, so I just switched it around the equal sign. That's a property I'm allowed to use. I'm going to add 5 to both sides of this equation to get that 6n equals 7m plus 7. And then to get n alone, I would divide both sides by 6, which means that n is going to be 7m plus 7 over 6. But remember, n is the same thing as f of m. So f of m equals 7m plus 7 over 6, which is, a legitimate answer. Oftentimes, though, they will distribute this division of 6, and you'll see it written more along the lines of 7/6m plus 7/6. So now try the same thing with this circumstance. Here you're asked to find a given input value x. The function g outputs a value y. Satisfy the following equation. 4x plus 3y equals 12. Write the formula for g of x in terms of x. So take a moment, do that, and then we'll go through it. So in this case here, we know that y is going to equal g of x. So we're going to take this equation and solve it for y. So taking 4x plus 3y equaling 12, we want to subtract 4x from both sides. I end up with 3y equaling negative 4x plus 12. I would then divide both sides by 3. And y is going to be that quotient, which often will distribute it. But remember, y is the same thing as g of x here. And if I distribute this division of 3, I'm going to have negative 4/3 x. And then 12 divided by 3 is 4. So g of x is negative 4/3 x plus 4 is probably the primary way you would see this expressed. Let's try one more of these. So if the input value is a and the function k outputs a value of b, that means that b is going to be a function of a, where k is that function. So b is going to equal k of a. And that means for our purposes here, we want to solve this equation in terms of b. So when I take this equation, I'm going to subtract 15a from both sides and get that negative 18b equals negative 15a plus 90. I would divide both sides by negative 18, which is essentially what b is going to equal. Now remember, b, once that's alone, that's the same thing as k of a. And this could definitely be simplified much more. Negative 15 divided by negative 18 simplifies into 5/6. So we have 5/6a. You even say 5a over 6 if you want to. 90 divided by negative 18 becomes a minus 5. So k of a equals 5, 6a minus 5 would be probably the most frequent way this function would have been written. And that is the end of this video. If you have any further questions, please make sure to bring them up. Until next time, have a good day.